Hi students, in this video we are going to cover the class 10 full organic chemistry chapter, and this video is going to be very important for the ICSE students. Their exam is in the next month, in the month of March, 11th March the ICSE chemistry examination is there, and also this will be very helpful for the West Bengal board students because they also have the organic chemistry chapter. So this will be starting from the basic concept and this is going to be very important. Please watch the full video. So here how we'll learn how the organic chemistry term comes. It was believed that the organic compounds only can be synthesized or made in living organisms like humans, plants and any other living organisms. And it was believed that there is some vital force is there which are responsible for the preparation or for the synthesizing of these organic compounds in the human body or animal body or plant's body. We cannot make organic compounds. It was believed that we cannot generate organic compounds in laboratory or artificially we cannot make. Only we can make inorganic compounds. But after that, after 1828, once that scientist comes, Friedrich Wöhler, he made urea, which is a good fertilizer, from ammonium cyanide. From ammonium cyanide, he got the urea, and after that, it was believed that we can make organic compounds in laboratory. And after that, there is huge number of organic compounds. This is how chemistry has evolved. So it was the introduction part of the organic chemistry, that after hitting ammonium cyanide there is a compound urea, and from there we get to know about that organic compound can be made artificially. Now organic compounds has one main element, that is the carbon. If you want to learn organic chemistry, organic compound, you have to learn about the carbon. Carbon symbol C is the main element of the organic compound. C, its atomic number is 6. If the atomic number is 6, the electronic configuration will be like this, that the k orbit of carbon will have 2 electrons and L orbit of carbon will have 4 electrons. And we know that the number of electrons present in the valence shell of an atom is called the valence electrons. So here the valence electrons of carbon is 6, and thereby the valency of carbon is also 4. The valency of carbon is also 4. Okay, the number of electrons present in the valence shell of an atom is called its valency. This concept is applicable only for till class 10. After that we will learn differently. We'll be coming to the class 11 and 12 videos. I'll make you learn about this. So here valency of carbon will be 4. Now we have to keep in our mind the valency of carbon means, the 4 means it has 4 hands. Carbon has 4 hands. Now there is a property carbon has, by that carbon can make huge number of organic compounds by forming multiple bonds. It can form carbon-carbon single bond, it can form carbon-carbon double bond, and it can form carbon-carbon triple bond also. Carbon can form, you can see what I have written on the board. I have written the catenation property. This is the property by which carbon forms carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond, and it can generate huge number of organic compounds. And not only carbon, as carbon belongs to group number 14 in the periodic table, silicon can also show catenation property, but silicon cannot make that many number of compounds that carbon can make. Okay, so what is that property by which carbon can form a large number of compounds? That is catenation property. Okay, now any compound which has carbon, that can be called as organic compound, except carbon dioxide, and some other examples are also there. Basically I am going to say that all the organic compounds must have carbon, but the inorganic compounds may or may not have. Okay, organic compounds are mostly soluble in water, insoluble in water, but inorganic compounds are mostly soluble in water. So you can learn 2 or 3 differences from your book. You can follow the ICSE concise book or any other book, it is available. Okay, you can see that, but the basic concept depends on here, that how the carbon makes compound. Now the organic compounds can be classified. Now before going into that, I want to tell you how the carbon form compounds. As I told you, carbon can form multiple bonds. The carbon carbon single bond can be formed. Between two carbon double bond can be there. Between two carbon triple bond can be there. Now carbon can easily form compounds with hydrogen, and the compounds which has carbon and hydrogen, they are called hydrocarbon. Okay, carbon can easily satisfy its valency with hydrogen. Now here, if between two carbon one single bond is given, we have to calculate the number of bond of the carbon. So here carbon has one bond. Okay, now we have to calculate 4 bonds. Okay, so one is there, 2, 3, 4. So now carbon has 4 bonds. Okay, here also this carbon has one bond. We have to calculate 4. 2, 3, 4. Now, as I told you, carbon can easily form compound with hydrogen. So here, these hydrogens we can easily give, we can easily write here. So we can get a compound. Okay, we'll name this compound later on. Carbon single one carbon can also make a compound. Okay, carbon with the single bonds. Now hydrogens can be easily written here because carbon can form easily bond with hydrogen. So this is a common compound, we all know. This is CH4, this is methane. We all know the name of this compound. Those who are in touch with the chemistry, they know that this is methane. But why it is called methane, how it will be called methane, what is the procedure to name this, okay, we'll learn later on. So here we'll draw just the compound. So this is a carbon carbon single bonded compound. Now here you can see carbon has double bond here. So this carbon needs to fill up with another 2 valences, another 2 bond, and this carbon also needs to have another 2 bond. We will satisfy the valency by the hydrogen always. Okay, here these 3 bonds are there, so one is here and one is here. Okay, so these 3 compounds we have seen. Let me tell you the common name of these compounds, except this one. This one is methane. This compound is called ethylene. Okay, common name. And this compound is called acetylene. We have a molecular formula of this, C2H4, and this is C2H2. This kind of formula is called structural formula, and this kind of formula is called molecular formula. Okay, so let us first classify the organic compounds, then I will tell you how we can write these formulas and all. We will go deep into this chapter. Okay, now organic compounds can be classified in 2 ways. Okay, first of all, one is aliphatic compound. These are the open chain compounds. And these are the cyclic compounds. These are the closed chain compounds. Now aliphatic compounds can be again classified as saturated and unsaturated. Okay, next, the closed chain compounds can be again classified as, the closed chain compounds again classified as alicyclic compounds and aromatic compounds. Okay, this unsaturated can be classified as alkene and alkyne. The saturated is classified as alkane. This is only the alkane. So this is the whole classification of organic compound. I'll tell you one by one. This aliphatic compound means when carbon forms open chain compounds, not a kind of circular or nothing, open chain compounds that can be made of single bond, that can be made of double bond, or that can be made of triple bond. So these are the aliphatic compounds. When carbon comes with the cyclic ring kind of shape or close, something which is close, that is cyclic. Now the cyclic compounds are again classified into words, alicyclic and aromatic, and these are the, in class 10 we have to just learn their definitions and some examples we have to learn. So here the aliphatic compound, let us start with the first. Aliphatic compounds are this. These are the aliphatic compounds. Carbon with only single bond, you are filling up with the hydrogen, this is open chain. You are forming compound with three carbons. So 3 carbon means 1 2 3. Now we have to fill up the valency. This carbon 1 bond, we are left with another 3. This carbon, the middle one, has 2 bonds already, 1 2. You can understand from here. So another 2 left here. This carbon left with 3. So if you fill up with the hydrogens, then you get one open chain compound. Okay. Now this can be branch also. Suppose I have written hydrogen here. Instead of writing hydrogen, if I write carbon here, so it goes in a branch. Okay, so find out how you can how you can fill up the valency. Again, let me tell you, these all are hydrocarbons because these are made of carbons and hydrogens. So what are the hydrocarbons? Hydrocarbons are the compounds which have carbon and hydrogen. So here this carbon has 1 bond, 2 3 4. This carbon 1 2 3 4. This carbon 1 2 3 4, and this carbon 4. So this is again coming in the branch. We'll name this one. This is going to be very interesting chapter, very interesting, and those who will see this full video, I can bet you they will never forget this organic chemistry. Okay, so this one is the aliphatic compounds, open chain compounds. It can have the double bond also. Okay, closed chain compounds are this. 3 carbons in a closed manner. Now valency of this carbon is what? 1 2. Another 2 is left. So if you can understand this part, how to fill up the valencies, how to find out the bond, carbon will not have more than 4 bonds. So that 4 bonds, if you can find out, it will be very easy for you. I'll name this on compound later on. So this is a cyclic compound, and cyclic compound will have the name starting with cyclo always. Okay, cyclic compounds mostly starts with cyclo. This can be another compound. I have taken 4 carbons here, and with 2 carbon you cannot make cyclic compounds. For the cyclic compounds, you at least need 3 carbons at least you need. So here it is 4. You can fill up the valencies by putting this. So you have got another one compound. This again an example of cyclic compound. Okay, we'll name this later on. Now, as you have seen in the classification, that aliphatic compounds, the previous one, is again divided in 3 parts: saturated. Now saturated, you can say hydrocarbon also. The hydrocarbons are 2 types: saturated and unsaturated. The saturated hydrocarbons are the single bonded compounds. Carbon-carbon single bonded compounds. And these are also called alkanes. These are also called alkanes. So saturated means single bond and they are mostly alkane. And the compounds which are alkane, their name will end with ane. This can be act as a suffix. ane suffix. Ane suffix means alkane, and alkane means carbon carbon single bond. Okay, and these are also called as paraffins. Paraffins means saturated. Okay, unsaturated means this can be carbon carbon double bond or carbon carbon triple bond. If a hydrocarbon has carbon carbon double bond, it is alkene, and if a hydrocarbon has carbon carbon triple bond, it is alkyne. Let me see the video is working on or not. Yes, so it is alkene, it is alkene, and it is alkyne. So carbon carbon double bond means alkene, carbon carbon triple bond means alkyne. So these two are also unsaturated. When double bond and triple bonds are there, they will be taken as unsaturated. Okay, so unsaturated means alkene and alkyne. So if somebody asks you name one unsaturated hydrocarbon, so you have to consider one double bonded compound. You can take the general name ethylene, as I said. If you take two carbon and put a double bond and fill up with hydrogens, you get this compound. Draw the structure of one unsaturated hydrocarbon having double bond or alkene. This can be one of the example. The common name is ethylene. Okay, this one is ethylene. And for a triple bonded compound, you can take this example. This is acetylene. This is acetylene. Okay, ethylene, acetylene. Now these are the saturated unsaturated hydrocarbon. Now let me take to the other one, the cyclic. The cyclic examples you have seen. Now in the cyclic example, you have seen two parts, alicyclic and aromatic. The alicyclic cyclic compounds are again classified as homocyclic and heterocyclic, but that classification I have not written because it is there in the class 11. Okay, alicyclic compounds are the cyclic compounds having carbon carbon single bond, double bond or triple bond, but not in a conjugated manner like this. These are also alicyclic. Okay, what is aromatic? In class 10 you have to only learn this one. One of the best aromatic compound is this one, C6H6, an aromatic compound with the molecular formula C6H6 having 6 carbon 6 hydrogens. It is benzene. Benzene is aromatic. Why? Because it has alternative double bonds which can change its place. This is benzene, and any aromatic compound, any benzenite compound is aromatic in nature. Any benzenite compound. This is benzene. If you change any hydrogen with anything, you will be getting aromatic compound. Okay, let me tell you the rule. A scientist was there whose name was Huckel. According to him, any compound which has 4n plus 2 number of pi electrons, planar in nature and cyclic, they can be called as aromatic. But this is not the part of your syllabus. You'll be learning all this in class 11 and 12. So I'm just saying this one, you can read this one, that anything which has 4n plus 2 number of pi electrons. Now what is pi electron? Double bond and triple bond, these bonds are named. depending on how they have met. In the double bond, one bond is called pi, the other one is called sigma. Okay, this one again I am saying this is there in the class 11 and 12, not in your syllabus. Okay, the one bond is called pi, other one is called sigma. In the triple bond, two bonds are pi and one bond is sigma, and this is pi means this double bond. Pi bonded electrons are called pi electrons. Okay, so which are available in this benzene. So benzene is what? An aromatic compound. Okay, so I think we have learned about the classification. Now let us go for the syllabus, the scope of the syllabus. We have detailed treatment of alkane, alkene and alkyne. So alkanes we'll learn and how to draw the structures of alkane. Okay, alkane, now it's a family. Once you increase the number of carbon, you get a family, a series of compounds in a family. So alkanes are the carbon-carbon single bonded compounds. They are saturated and they end with the name N. Now organic compounds can be drawn or can be represented in a different way. Okay, and those are called formulas. The organic compound formulas are classified in these ways: number of carbons, then you have structural formula, okay, then you have condensed formula. The organic compounds can be formulated in three different formulas: structural formula, condensed formula and molecular formula. Suppose organic compound has one carbon, which is single bond. One carbon single bond is possible. Okay, now you have to fill up with what? Hydrogen. Because it is a hydrocarbon, alkane comes under the hydrocarbon. So this is what? A compound which has carbon hydrogen single bond. Okay, single bonded compound. What is condensed formula of this? How to write the condensed formula? One carbon and surrounding hydrogens. One carbon surrounding hydrogens, CH4. Here also for the molecular formula you have to count totally the number of carbons and hydrogen. Now for methane you will not understand any difference here. But once you go for the next one, number of carbons 1, number of carbon 2. Here 2 carbons, single bond. How to fill up the valency? With the hydrogen. This carbon has 1 bond, 3 bonds are left. So this formula is the structural formula, expanding all the bonds, structural formula. Condensed formula, 1 carbon, 3 hydrogens. So 3 hydrogens, 1 carbon. Then what you have? A single bond. A single bond, carbon and 3 hydrogens. Condensed formula means 1 carbon surrounding hydrogen, then the again another carbon, the hydrogens. This is the condensed formula. And how to write the molecular formula? Totally C2H6. Okay, like this you can increase the number of carbons. Suppose 3 carbons are there. This carbon, 3 bonds. This carbon, how many bonds are left for the central carbon? Tell us. This central carbon, how many carbons are left? How many hydrogens are left here? 2. So this is single bonded compound having 3 carbon. How to write the condensed formula? How many hydrogens are here? 1, 2, 3. Then bond CH2 bond CH3. Molecular formula C3H8. Okay. Now I'll do till 4. The rest work is your. Okay. If you have any doubt, you can comment on the comment box. I'll surely reply this one. So here, number 4 carbons, 4 carbons here. We'll have single bond here. Now fill up the valency with the hydrogens. This carbon, how many valency? 1, 2. And the 2 are left, 3, 4. H3C, CH2, CH2, CH3, C4H10. Okay. Now these are the, you can go till the 10 also. Okay, till 10 carbons alkane you can generate. Okay. Now in this series of compounds, what you can see from the first to second. In the first compound, how many carbon is there? 1. How many hydrogens are there? 4. In the second compound, 2 carbons, 6 hydrogens. So what is the difference of carbon here between these two? 1 carbon. And what is the difference of hydrogens? 2 hydrogens. So in a series of compounds in alkane, you can understand that there is a difference of CH2. Here also a difference of CH2. Here also the difference of CH2. So when in a series of compounds, in a series from one to other compound, the difference is CH2. That series is called homologous series. So this one is homologous series. So in homologous series, what is the difference of the back-to-back compound? What is the formula difference? That is CH2. So alkane is a homologous series. Okay. Now we can understand the general formula of alkane from here. You tell me, see, 2 carbons, 6 hydrogens. You can see from here, the number of carbon is 2. The hydrogens are 2 greater the twice. 2 carbon is there, hydrogen is 6. That means what? If you take n number of carbons, the hydrogen will be 2n plus 2. Okay. The number of carbon is 2. The hydrogen is 2 more than the twice of the number of carbon. 2. Hydrogens will be 2 into 2 plus 2 here. So the general formula of alkane is CnH2n plus 2. CnH2n plus 2. And if you can remember this can come as a short question also. In MCQ also it can come. And if you can remember this, if somebody asks you, an alkane has 40 carbons. How many hydrogens will be there? So what you have to do? 40 into 2 plus 2. So it will be 82. An alkane has 10 carbons. So how many hydrogens? 10 into 2 plus 2. So it will be C10H22. This is the general formula of the alkane. So what is the general formula of alkane? It is CnH2n plus 2. Okay. Now let us come to the family of alkene. For alkene, it will end with in and it is C double bonded C. Okay. Similarly, the number of carbons, then the structural formula, then the condensed formula, then the molecular formula. Today in this video we'll be learning till the isomerism part, and from next day we'll deal with the alkynes reaction. Okay. I don't think I'll be able to finish this one because it will take much time than I was thinking. I was thinking that it will be finishing it can finish within 1 hour, but it will take more time. So the video is getting bigger. So number of carbons for the alkene, you at least need 2 carbons. For the alkene, you at least need 2 carbons, because with the only 1 carbon you cannot make. So structural formula, and hydrogen do not form double bond. So to make an alkene, you need at least 2 carbons. With 1 carbon, you cannot make alkene. Okay. So this carbon has 2 valency, another 2 bonds are left, 3, 4. Okay. Condensed formula, H2C double bond CH2. Always in the condensed formula, you will try to show the bond between 2 carbon. Okay. Molecular formula is C2H4. If 3 carbon, for the time being, we'll learn many reactions, many structural formula we'll learn. But for the time being, let us put the double bond in one of the terminal carbon. We can number this carbon 1, 2, 3. Let us put in one of the terminal carbon here. Now let me tell you, if an organic compound has at least one double bond and other bonds are single bonds, that compound is considered to be an alkene only, a double bonded compound only. Okay, so this one between these 2 carbon, a single bond. Now this carbon has 1 bond, so 3 bonds are left. This carbon has 3 bonds, 1, 2, 3. Another 1 bond is left. This carbon has 2, another 2 bonds are left. So now here H3C, CH double bond CH2. This is the condensed formula, and this is the molecular formula, C3H6. Okay. Now let us go for the fourth one, carbon. Now as I told you, I'll show you with 4 carbons, the rest all 6 will be SW. So here let us put the double bond at the terminal. I hope that you can understand. If you have any doubt, you can tell me in the comment box. So I'll try to rectify myself also. H8. Now these all again the alkenes, and you can understand from here there's a difference of CH2. So these are again the homologous series, part of the homologous series, and here the general formula of alkenes is the number of carbon, if it is n, the hydrogen is double. See, 4 carbons, 8 hydrogens. So if somebody asks you, an alkene has 12 carbons, how many hydrogens will be there? It will be 24. Okay, so this is CnH2n. The general formula of alkene is CnH2n. Okay, let us go for the next one, alkyne. For the alkyne, for the family of alkyne, similarly we'll try to put, for alkynes also we need at least 2 carbons, and hydrogens are placed like this linearly. Okay, always we put like this. Condensed formula is this one and molecular formula is this one. If 3 carbons are there, we'll try to put the triple bond at terminal, as we have done the same for the alkene, as we were learning first time these organic compounds. It will take time. Okay, this one, this is C3H4 triple bond. This carbon has 3 bonds, so 1 left, and the other will be a single bond. We'll put a single bond as we were learning the first time. As I told you, we'll be making many structural formulas. We'll put multiple triple bonds, double bonds, but first of all, as we were learning first time, we'll go like this. Okay, C4H6. Now here also you can see the difference is CH2. So this is also part of a homologous series, and the general formula is CnH2n minus 2. The number of carbon, if it is N, for the alkyne the number of hydrogen is 2 less than the twice of the number of carbon. That means if an organic compound has 50 number of carbons, in an alkyne the hydrogens will be twice of 50 minus 2, that means 98. This one. Okay, now this is the basic concept. Now in organic chemistry, as we have learned that methane is a compound, ethane is a compound. Now ethane I did not talk about here. Let me tell you this. We can name the organic compound by, and for that we have a rule that is called IPAC nomenclature. Now this IPAC nomenclature has a general rule. I'll not go detail to this one in this video. We'll start with this, but next part we'll be doing on the next video. For the IPAC nomenclature, the number of carbon, the name of the organic compound depends on the number of carbon and the type of bond. Firstly, if the number of carbon is 1, the name will be meth. It will start with meth. If it is 2, it will be eth. If it is 3, it will be prop. 4, it will be but, not but. Okay, it will be but. For 5, it will be pent. For 6, it will be hex. For 7, it will be hept. For 8, it will be oct. For 9, it will be non. For 10, it will be dec. And for single bond, the name will end with in. For double bond, it will end with in. For triple bond, it will end with ein. Now let us finish this today's video here only. I'll start with the IPAC nomenclature, functional group, and all the reactions will be done on the next video. We're coming quickly because I know you have the exam on 11th, and this is also for the students for West Bengal Board students and the class 11 and 12 students also. The coming 11 students, they can also watch this video. It will be very helpful because sometimes you forget, but if you want to go with the chemistry, if you learn more, this has to be revised. Okay, so thank you for watching this video.